Okay, so on page 6 of your lab book, list the type of bonds between the following sets of atoms. So NAP, CNO, H and O, N and O, C or K and CO. You don't want to keep that forever. Okay, give that a shot. Here, I'll keep it because it's beautiful and I've never done it before. So this will remind me next time I do this. Thank you. All right. Look at your lab partner and say, I have either, I know exactly what I'm doing or I have no idea what I'm doing.
I'd like to pretend I know, but I don't. I really, but I'm going to try.
Do you have a periodic table? Oh, I really do. Okay, keep going. Okay, keep going. Try your best. We'll show you how to do it. We're going to use these numbers right here when we start doing this. You're welcome. All right, take about 2 more minutes. Raise your hands if you have no idea what you're doing. Just a couple of you. Okay. How's it going over here?
Don't say that.
Why am I confused?
We'll get unconfused.
Do you know what to do?
A little bit.
A little bit.
Okay, so this number, right?
Yep.
0.9, and then heat. So do you like add them over?
No. You subtract them.
Okay. So
Small from big. No. Small from big. It should always be positive. That means the big number comes first, then the minus sign. All right, who's done? Anybody? Nice. Good work. Power group right there. You're done, 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 done. Colby, done. All right. We'll get you on that. Here we go. For those of you that raised your hand and said you had no idea what to do, make sure you pay attention. Oh no, I've broken this. Okay. What we do is we find Na and P on this part, on this periodic table. So we look at Na and we find this number right here is at 0.9. We okay with that? All right, then we find phosphorus and it is right here. Is that correct? So I have 2.1 and 0.9. I always go big minus small. So that means the big number, the big one of the two is 2.1 minus 0.9. And that would equal 1.2, correct? All right, I got to sneeze. All right, that was through a mask and through 2 layers of shirts. I think we'll be all right. Shouldn't affect anyone. All right, 1.2. So the next thing we would do is look at this chart. 1.2 puts it, I don't know, how about around here? Sound good? So I come up and look, and it tells me that that would be a polar covalent bond. Yes, sir. No, nope. And honestly, in about 5 minutes, we're going to say we'll never use this chart again anyway, because it's somewhere else. All right, next, C and O. So was it 3.5 minus 2.5. Is that this one? And that equals 1. So that would be what? Polar as well. Who's with me so far? 2 for 2. All right, this is getting old. H and O ended up to be what? Was it 1.4? And that was polar. Oh man, are they all polar? No. N and O is what? I better look. All right, so N is a 3. O is a 3.5. Big is 3.5 minus a 3 equals 0.5. Finally, something different. We would say this one is non-polar. We're going to learn that in the next 48 hours. So it really has to do with how they share things. If they're non-polar, they share equally. If they're polar, they share, but not very well. Like there's probably at least one of your siblings that you don't share very well with. Is that right, Curtis? A lot. So that would be a polar type relationship. Both. All right. K and Cl, was this the only one that was ionic? Okay, who went 5 for 5? Raise your hands. All right, then you can definitely do that part of the test. Now, here we go. We've been referencing this chart. Make sure you're with me right now. You cannot use this chart on your test, but you don't have to memorize. How come, Jared? Because it's right on your periodic table. Will you look to the far right side of the periodic table you've been looking for? You will notice those values are written right here. So we're going to fill in these coming up. So don't write anything else yet, but just notice, whoops, I don't want to undo the highlighting. So we'll just undo the circles. That an ionic bond has a difference greater than 1.7. A polar covalent bond has a difference between 1.7 and 0.6. And nonpolar are differences less than 0.6. All right. So that graph or that table or whatever you want to call it, it is just right here. So you will not need that table. Yes, sir. If you have 0.6, it would be here. It has to be under 0.6 to be down here. Now, I don't have one on the test that's 0.6 or 1.7, so that there's no confusion. All right. We all right with that? Okay, so if we look at the daily plan, it says today we will wrap up how to determine bond types. So that was what we just did. And we'll fill in page 10. So we'll go there. We will use the data from page 10 to fill in the right side of our periodic table we have been working on. So once we have that data, we will then work on problems 37 through 42 and the homework on page 16. So big day. As far as test is concerned, hopefully you feel confident about your ability to determine bond types. If you were just able to do well on that little assessment we just did, then that's a solid, easy check mark. Find the 2. Take the big number and subtract the small number from it. And now look at your periodic table. If you guys are going to talk this much, you can go sit over in that storeroom. All right. Are we good on that? Super, super not bad. Now, this will be the rest of the hour. Once we know how to determine bond types, then we need to know how to determine the properties of the bonds. Now, we haven't done the notes on the actual bonds yet. They're not bad. We will learn all about ionic, polar, and non-polar covalent bonds and metallic coming up. But for now, we're going to learn about the properties of these type of bonds. So if everyone would turn to page 10, you will see a very large data table. Let me clear this out for next hour, though. It is. But we can do it. I believe in you. All right. Look roughly like this. All right, this is usually a lab, but I haven't done it in 6 years because it makes me sick. So I decided, why would I do something at my job that gives me a headache for 2 days? So what we're going to do is we're just going to fill in the data. So the first thing we're going to do, this will be like the name of the substance, and then this will be a drawing of its structure. Now, you do not have to draw structures on your exam. So go with me as we do it, but don't stress if you struggle a little bit on that. Then once we have the formula or the drawing, we should now be able to determine the type of bond. So let's just go ahead and jump in here. So what you'll do, this is the picture, and this is the substance. So water, and then the picture, you'd have an O, an H, and an H. We okay with that? Okay, the next thing you would do, and we did this one already, you would look on your periodic table and say, all right, what's the difference between O and H? And someone said, was that you, Ethan? It's what? It's polar. The difference is 1. So when you look at the thing on your periodic table, you would now know this is polar covalent. PC is just fine with me. Okay, now the structures get very complicated for a little bit. So just kind of look up there. You can complain or you can just fill them in and move on. So here is hexane. The hex means that there are 6 carbons. That it ends in A and E, that means that they are all saturated with hydrogen. Hexane. You do not need to know this, but hexane is what we call a non-polar solvent. So like when we have permanent markers, like a Sharpie, it really is only permanent because it doesn't wash off with water. But if I were to take hexane and I like tried to clean off my board, let's say someone wrote with Sharpie on my whiteboard up there, I could get hexane out and it would wipe it right off. So it's like water, except for it is a non-polar solvent. All right, so we have that. Well, hold on, come back here first. So hexane was all that stuff. The type of bond, hexane was huge, but it really was just a bunch of C's and H's, right? So you would do the math to find the difference between a C and H. And if you paid attention to what I just barely said, you would already know the type of bond. It's nonpolar. So I'd put NPC, unless you can write really small. All right, the rest of them I'm not going to do for you, like this column, we'll draw together. So the next one is NaCl, or salt, and it is just Na-Cl. That one wasn't very hard. Okay. I'm just going to go down the list to draw them now. You can figure out their bond types later. This is the hardest one to draw. I'm aware of that. If you just kind of put the 2 C's in the middle and then build around them, it's usually a little bit easier. And it doesn't have to be perfect. Just do your best. Yes.
Oh, there's a whole other circle?
Yep, this is the main component of old people smell. If you've ever gone to visit your grandparents, you're like, man, it smells weird in here. Well, that's naphthalene. Naphthalene is the component that makes mothballs stink. And mothballs are things that old people put in their closets to keep moths from eating their clothes. Young people, we don't buy clothes that are actually made out of natural fibers anymore, so it's not as big an issue. All right, so naphthalene, while some people are still drawing, other people might be able to figure out its bond types. Naphthalene is a very large molecule, but ultimately it's just a bond between what two atoms again? C and H, correct? So we've already done C and H. I'm not. What happened? It's okay. It won't. Well, don't erase anything.
Put an arrow over there.
Yeah, that's fine.
What is it called again?
Naphthalene. So the picture goes here. The name goes here. All right. I am going to move on though, James. We can come back to it later. All right. So that's naphthalene. It is a nonpolar substance that is solid at room temperature, which is actually pretty rare. Most nonpolar substances are gases or liquids at room temperature. Uh-oh, I got that upside down. Okay, next, pentanol. This is the last hard one. Last hard one to draw. All right, this one's tricky. Whenever you have more than two types of bonds, because you'll look here, we have C's and H's, we have C to O, we have O to H. We're going to look once again at this part. The majority of this one is C's to H bonds, which we've done plenty of times. All right, so this one would be considered nonpolar again, because the majority of this atom, like overwhelming majority of this atom, is just carbon bonded to hydrogen. What's that? Well, that's coming up in the next one, I think. So methanol. Now we're getting a lot closer. This one's kind of hard to see. I don't know if that actually helped very much. Okay, methanol. Now, that's what I was asking. Now we're about half and half. We're at C's and H's, and then CO and CH. When we have one about the same size, then we need to check the most electronegative atom, and we would look at its bonds. Both the bond to here and both the bond to there are polar bonds. So since methanol, even though it's very similar in structure to pentanol, methanol will be polar because the oxygen, hydrogen, and oxygen carbon bond is now a greater percentage of all the bonds. Okay, kind of tricky. Let me group all this real fast. What? Then we'd have to really get specific and probably look at the data, like how it reacts and stuff to know. So yeah, if this was to another C and H or something like that, it'd really get harder to do. No, not at all. All right, this one is called copper 2 sulfate. So here's your name, here's your structure. All right. Now, this one could be tricky, but if you would look on your periodic tables right here, when we talked about an ionic bond, it has differences greater than 1.7, but what does this first part say? It says one atom is a metal and the other one is a non-metal. So anytime we have a metal non-metal combination, even if the math is different, we're going to say it is an ionic compound. So copper 2 sulfate, we would say it is ionic. What's that? What do you mean? This thing right here, this whole thing is one happy little beast that has stolen electrons from copper to complete its octet. Anytime a metal gives up its electrons to anything non-metallic, it forms ions and we end up with an ionic bond. So the electronegativity won't really matter on that one. So we say since it's a transfer of electrons from metal to non-metal, we call it an ionic compound. Okay, now this is iron, and then just put Fe dash Fe dash Fe. All right, now this one, you won't do any math at all. And it's not nonpolar. I know that's a difference of 0. If I just have iron, I have a piece of metal. And a piece of metal has metallic bonds. So the type of bonds between just individual metal atoms is called a metallic bond. Okay, then the last one is just like it. It is copper. So once again, if I ever have just the same metal over and over, it literally just means we're talking about a chunk of that metal. So it's a chunk of copper. And a chunk of copper is composed of copper atoms that are metallically bonded. All right. So do we have all of the data table filled in? Unless we were playing a game on our phone. We have those 2 columns. Okay. The next slide is all the data. Now, double check. I think I have it in the right order. Don't write anything before I check with Amber here real quick. Sorry, I stole this. Okay, that's in the right order. So just go ahead and start filling that in. Take a minute or 2. We usually get this data out of a lab, but like I said, this one gives me sore throat and headache. And I lose my sense of taste. That was a joke. Thank you. All right, how we doing? Oh, you need that bottom row. The bottom row is the same. Well, I can probably get it there. There you go. Oh, there's up and downers and there's left and righters, aren't there? Hold on. Oh. Okay, there it all is all on the same page now. Way to be a fast writer. Yep. I didn't know they were correlated, but now I do. Right here. That means it decomposes. So what it's saying is that CuSO4, before that compound will actually go to a gas, it just breaks apart into copper, sulfur, and oxygen. All right, who needs more time? Raise your hands. Okay. I got all day. The swim me at Olympus? Oh. Oh, our preview's in the way. My bad. Okay. Now, let's figure out what on earth this data is supposed to tell me about the stuff on the far right side of my periodic table. So if you will keep your table handy, this data table, and look at the far right side of the periodic table, I'm going to have to go back right here. Okay. So if we look on our data table at the substances that are ionic, and we look at their solubility. Now, just an FYI, in case you don't remember from chemistry A, solubility means the ability of a substance to dissolve in something else. So when you look at your ionic data table, let me arrange these closer in the notes. When you look at the data table for the two things that were ionic, did they dissolve in anything? They dissolve in water. Do they dissolve in anything else? No, they do not. So actually, you know what? I think I already had it there. Oh, look at Tom Davidson. I was prepared in advance, but forgot I was prepared in advance. So what you are going to do, and make sure you write this really clear so that you get the test questions perfectly right. When you have an ionic bond, its solubility is in water only. Okay? Now, it would dissolve in other polar substances, but I'm not going to name another polar substance. I'm going to name water. So a test question, the way it'll work, you'll have to do the math and you'll figure out, hey, NaCl is an ionic compound. And then the test question will ask, does it dissolve in water, hexane, both, or neither? And your answer would be water. Easy enough. Okay, now, conductivity means the ability of the substance to conduct electricity. So we come back here, this is ionic, and this is ionic. Conduct in pure form? No. Where is it? Dissolved? Sorry, I can't speak. Conducts when it's dissolved? Yes. So we're going to go to our table, and we're going to say it conducts in solution only. Because you have to be careful there. The test question will ask you, will it conduct in pure form? And you would say, no. It might also say, will it conduct in solution? And then you would say, yes. All right. Malleability means, is it brittle, which means does it crush when hit, or does it bend when hit, which is malleable. You come over and notice both of them are brittle. So for malleability, you're going to write the word brittle. The question on the exam would say, is it brittle or malleable? After you've done the math and you knew what it was, you would say ionic, they are brittle. Okay, MP and BP, that means melting point / boiling point. And we're just looking for high, medium, or low. So you look at these values and comparatively, do they look high, medium, or low? They're pretty high. They're not as high as metallic, but they're still very high. So you would put high. Okay, combining our ability to do math and figure out the type of bond, and then this data, we can find the type and properties of any type of bond that we have in this class. Okay, looking at polar substances, same idea. Whoops, this way. So now my polar substances were water and methanol. The first question is, do they dissolve? And it looks like they dissolve in water. Now, water, does it dissolve in water? Sure, yes, no, it's just water, but methanol does. Naphthalene was non-polar. Yeah, naphthalene was just C's and H's and C's and H's and C's and H's. So this should be non. So just these two are your polar. So their solubility is the same as ionic, water only. Looking at your data table, did they conduct electricity ever?
Nope.
They did not, so you put none. They have no conductivity. So most people don't realize this, but pure water itself does not conduct electricity. Just dirty tap water does. Dirty bath water definitely does. So don't curl your hair in the bathtub. All right. Malleability. Are they brittle or malleable? Okay, they are liquid. We wouldn't put neither. When we ask about malleability, we're talking about it as a solid. So if I freeze ice, it's brittle. And on the test, to clarify that, it will say, is it brittle or malleable as a solid? Go ahead.
What's the difference between non and non?
Say that again.
The difference between non and non-polar?
Okay, so what non-applicable means is if I'm seeing if water dissolves in water, that really doesn't apply because it already is water. So yes, it mixes, but we wouldn't say necessarily water dissolves in water. So none, we'd say, all right, I dropped this in and none of it separated versus Na, which means it's the same thing, so I don't really describe it. All right, and then melting point and boiling point, these are the ones that are medium. Okay, coming back, my nonpolar substances were hexane, naphthalene, and pentanol. All right, do they dissolve in water? No, no, no. But what do they dissolve in? Hexane. So on this, you'll put hexane only. All right, checking the data. Do they ever conduct? Tell your partner if they ever conduct. Okay, so the answer is none. Tell your partner if they're malleable or brittle. They are brittle. Now, once again, most of these are gases or liquids at room temperature, but as a solid, we would say they are brittle. Then melting point, boiling point, these are the very low ones. Then our metallic bonds. That's a metal atom bonded to a metal atom. Solubility, you should notice that they did not dissolve at all. Conductivity is only in pure form. So we know metals conduct, but don't get tricked on the test. If it says, does it conduct in solution? The answer would be no. It doesn't even dissolve, so it doesn't make a solution anyway. They only conduct in pure form. Then metals are the only ones that are malleable. So if you hit your car with a hammer, it doesn't shatter, it just dents. And that's because metals are malleable. Some of you may have composite cars, so they may do like crack, but those are pretty rare still. Melting point, boiling point, these are usually the highest. Okay, now we have a lot of data on this paper. You get to use it on your test, so make sure you don't lose it. Turn to page 16 and we'll try and do some stuff real quick. Do I not have it? Oh, I don't have it. Could have sworn I had it on here somewhere. I think I have it on another one. Okay, maybe. Page 16 should look exactly like what we just did, right? Oh, let's take a while to find it on here, but I know it's in here somewhere. Oh boy, come on. All right, here we go. For right now, speed-wise, don't worry about this column. So let's look at KOK. We'll skip this for a second, and let's determine its type of bonds. So you simply find K and O, take the big and minus the small. Whoops. Is it 3.5 minus 0.9? Okay. So what would we consider this? It's ionic. And once you know it's ionic, all these questions are a piece of cake. We just look at our data table. So do ionics dissolve in water, hexane, both, or neither? Water. Do they conduct when dissolved? No, because they don't dissolve, right? Do they conduct in pure form? Or no, whoa, hey, I'm sorry. You're all looking at me wrong because I'm an idiot. I was thinking metallic still. So do they conduct when dissolved? Yes, sorry about that. Do they conduct in pure form? No. High, medium, or low? High. Is it malleable or brittle? That's not hard, right? That's not hard. We will do these. These are the hardest part, but they're not tested, so don't stress about that. Okay, apparently we're close to getting out. I can sense the energy.